Alright, today we're going to get into some situations where we begin to manipulate logs, and the first way we're going to manipulate them is by switching them or converting them from exponential form into logarithmic form, and vice versa. Now, we spent 2 days talking about parent functions of the exponential and logarithmic equations, so we'll go ahead and begin our focus today with that. Now you're going to notice in here there are some very big similarities. The base of the exponent is the same as the base of the log. Notice then that what was the exponent now becomes the argument of the log. So that's a very important recognition when we solve these problems, when we convert these exponents into logarithms. So your basic form of an exponential function looks like this. Of course, we can have all these transformations applied to it, and that can be switched into logarithmic form and vice versa by using this basic switch here. So you'll notice that the bases stay the same, but the other two values switch their order. The base becomes the base of the log, and then the argument and the exponent switch places. Here are some simple transformations or conversions from one into the other. So the base remains the same. Log base 3 of 81 equals 4. Log base 6 of 6 equals 1. Log base x of 1 equals 0. Log base 5 of 1/25 equals -2. Log base 3 of 5 equals x. And finally, log base 8 of 4 equals 2/3. Now we're going to convert from logarithmic back to exponential form. So it's going to be 3 squared equals 9. X to the third equals 8. 6 to the -1 power equals 1/6. 3 to the first equals 3. 15 to the 0 power equals 1. And 81 to the 1/2 power equals 9. We're also going to talk about some special properties of logarithms. These are very simple, but it's very important that you recognize them, because when you're expanding and condensing logs, they will become very handy in order to solve these problems. So if the base and the argument of a logarithm are the same, the answer is 1. If the argument of a logarithm is 1, the solution is 0. These are easily recognized by looking at converting this back into exponential form. So 10 to the blank power equals 10. Well, that's the identity, so it's got to be 1. 16 to the blank power equals 1. And that's the 0 property when we're talking about exponents. The answer here is 1, and the answer here is 0. Evaluating these logarithms is very simple. You simply put in your equation equaling x. Now this brings in a very important point. Notice all of these logs before all had bases, and this one all of the sudden does not. If a log does not have a base written, it is assumed to be base 10. So please recognize that a log that has no base is not log base 1, but instead log base 10. So I'm going to go 10 to the x power equals 1,000 by converting it into exponential form, and the evaluation here is that that's a 3. And this is going to be a -5 when you convert it. This one is going to be a 2 because it's 4 to the x power equals 16, and that's going to be squared. In this case, it's 4 to the x power, which equals 1 over 16. Well, it's still that 2, but what does it take to move it to the bottom? Properties of exponents. It's a -2 this time. 1/2 to the x power equals 4 is the way you would evaluate e. And you'll notice now I've turned a fraction back into a whole number. What does it take to turn the 2 into a 4? That's got to be -2. So now I'm going to do 5 to the x power equals 25 times the square root of 5. And now what I'm going to do is I'm going to write this out using properties of exponents. 5 to the x power equals 5 squared times 5 to the 1/2. Once you add those two together, you get 5 over 2. So that means this one is 5/2. In this one, you get log base 7, so that's 7 to the x power equals the cubic root of 49. Well, that's going to be 7 squared over 3. Everybody catch that? Let's try again. Using properties of radicals, I'm going to convert this into a rational exponent. Remember, I need the base of my exponents to be the same to use properties of logarithm or properties of exponents to evaluate them. So that's the cubic root of 7 squared. Turning this into a rational exponent means I'm going to make that 2/3. So now it's a straight conversion. X equals 2/3. Okay, so those properties of exponents do come in handy. We need to make sure that we are continuously reviewing them and keeping them fresh in our minds so that we can be successful. All right, question number 4. Well, what we're going to do now is we're going to start solving these logarithms, which is much like evaluating, but now what we're going to do is do that conversion with the x value already written in. So that one's simple, straightforward. The answer is 2. X to the first power equals 4. Remember, that's the identity, so that means it has to be 4. Now we're going to say 3 squared equals x minus 5. 9 equals x minus 5. Adding 5 to both sides gives me my solution of 14. X to the 1/2 power equals 6. Remember, that's like saying the square root of x equals 6. Well, that's got to be 36. 2 to the 3x power equals 32. Can I change the number 32 into a number that has a base of 2? The answer is yes. 3x equals 2 to the 5th. Again, properties of exponents show up here. Drop your bases. 3x equals 5. That means that x equals 5/3 is your solution. And finally, b to the 3rd equals 64, and b has to be 4. Now, question number 5 and question number 6 are not solving because they are not equations. Instead, we're going to simplify. Alright, so when the base of an exponent and the base of a log are the same, they cancel, and the argument of the logarithm is the answer. Special properties of logs. When the base of an exponent and the base of a log are the same, they cancel, and the argument is the answer. And that is your first introduction to solving, simplifying, and manipulating logarithmic equations. Please make sure you review your properties of exponents so they're fresh in your mind, so that you can continue to have success simplifying logarithms and solving logarithmic equations.